Hey guys, here we go. We start from the line on the floor, which is my power, into a regular old good-fashioned amp meter, as you can see there. Okay, that's gonna need, all you'll see is a 15 amp maximum. That's for testing small appliances and stuff like this. You know, you just plug it in and there's a switch that can give you power on both sides. So I'm running on this side here. So, and then I got a nice loop here I put so I can put my digital readout for my amp, which is this wire here, the load wire. It goes connect right through this cord all the way up to this hand automation, which is a brushless speed controller. Now I got that all wired up, all the sensor put in place. As you can see, that's where the sensors are. They were a bit sorry for that, for the shaving there, but I'm trying to get a good picture. It was a little bit of tricky to put those sensors there, and I found out the simplest solution was the best after I went through many different solutions. They're very complicated. Very simple. Piece of foam stuck between the stator, and crazy glue the sensor to the piece of foam between the stator. And a story. Doesn't cost much money. So anyway, what we'll do is we'll turn this guy here, but for some reason I have to talk to the Hein tomorrow on Monday to make sure my sensor are at the right position. You know, it's three color wire, the yellow or white, green and blue, if they're the right sequence. But to me, it seems to be in the right sequence because it runs too smooth. Now, sorry for that. I'm gonna start this motor and you will hear the sound. See? It's turning. It's turning. I can make it go faster. But it's only turning at 240 RPM. Okay, that's the one who's powering. That's the one who's the motor. Right? That's the motor at 240 RPM. You can see the coil through the fan. Alright, and it's powering this yellow one, this yellow green one, and I have a load here. I managed to be able to make 3 volts, 3 volume, 118 volts on this wire here, the brown wire. Okay, 118 volts. This wire here, the yellow wire, have 120 volts AC, and this green wire here have 168 volts because I put the cap between the two, as you can see on the cap. So I'm shooting 2 legs on the cap, 1 leg's open, so I have a spare legs here with 118 volt coming out of it. Now, as we see, we're not using nothing for power. The needle is at 0. Now I'm going to put my digital amp meter and you will see, right, 0.7. Alright, and I have no load, so I have 0 load here because I didn't connect nothing. But this is the monster dryer of my daughter. A Conair has 1850 watts of draws. Now I'm going to turn just the fan, the blower, to show you it works. As you can see here, the fan works full blast. Right? And the fan, as you see, put some load on it. Because now I'm using, let's put that on here. Off the wall right now I'm using 1.8 amp. Now let's go see in my draw how much I'm getting. Alright, so we know a difference right there. That's just the motor. Now, I'm going to do something else now. I'm going to roll that to full with all the heat, but the motor will slow down. For the reason being is because I don't have enough juice to come in. I'm only turning, remember, 240 RPM, right? So I'm going to put it on high on the heat. Okay, now I'm a solid draw. Now let's see what we get in here on the meter. 1.75. $1.10. Okay, that means at 1.75 in my, I'm putting out more than what I'm putting in right now. Over half an amp more. On 1.72. Let's go back to the wall. $1.10. And something. I'm making more out of the machine than I'm putting in out of the wall. This is like, where is happening here? Now I thought I was making more than that, but right now I got 1:3 ratio over unity. You know, that's pretty good. And half an amp for a 1 amp draw, a difference, like that's a lot. And everybody, I have nothing inside beside a straight shaft with spin with the bearing. As you can see, it's not a thing but a nice little shiny thing. That's my shaft through it. There's no Houdini in there, nothing. Nobody with a mechanical device was capable of producing more out of the wall. It's impossible. You should not be able to do that mechanically. And even with this thing, not even running at the right speed, I'm supposed to get 4,000 RPM out of this thing. And then bring my volt down, because I'm going to produce thousands of volts, and then I can bring it down and then manage this volt, and with not using much more than what I'm using today on power, you know. So I can loop that up really easy. And there it is. That's full draw, and look at the needle, barely moving. Now watch that. I'm going to put another draw on it. Now you see the needle, it doesn't slow down, you just draw a little bit more. But this motor's got so much power with that thing, it's just amazing. So let me rearrange that. And we can slow that right down to early no movement. I'm at full load right now with the hair. And look, the noise. Those are humping from the magnet. What you're hearing. Everything is vibrating. Now let's see my load. Again, what I'm pulling right now to turn that really slow. Now I'm in half an amp. Now let's see what my load is. See? Again, the same gain. And I'm still maintaining turning this thing. I mean, this thing is turning slow. Look at that. Very slow. That's how much torque this thing's got. It's just amazing. So let me put all my stuff away here. And the caps, very simple connection, as you can see. Now the caps can be different. That one's at 370 volts. So I mean, like, you know, it might be a little high, it might be a little low, but that's trial and error. And again, that was no load. Remove the load, nice and smooth again, and you can really slow it down. Look at that. Start it again. I mean, I have total control of that motor. The only thing is, Anaheim can tell me what I got to do, or maybe they have to readjust or send me a chip. Is a removable chip, a timer chip in there? So maybe that chip is made for less leg motor than I have right now, because I got 36 legs. So let's turn the toys off. So guys, that's what's going on here right now. Boy, I'm telling you, time is very precious for me because I don't have a whole lot. Just today, it was about a dozen tests and different things, including making power, but I was not working on that already, but I decided, oh, well, let's try it, whatever we can do. Those things just gave me a hell of a surprise. But again, my understanding of the natural energy is, if you have a drum slightly smaller, you can do massive amount of energy with very little to turn it. And the law is very simple. You can't move a mountain, a certain size mountain, with exact same size mountain of energy. It doesn't work. That's called equality. So when you want to be, you know, you want to do some amplification, you cannot demand at the same distance between the center of the shaft and the outside of here, you cannot demand the same torque, because now you're breaking the rules of natural laws. It's like a seesaw. You know, when you go in school, and we used to put a piece of 2x8 across a sawhorse, and we were, you know, going up and down, right? But the thing is, if you have an equal balance, an equal distance on both sides, you have to have exactly the same amount of weight on each end so you can go up and down, right? What happened when a kid who's like twice your size go in one end? Well, it's an off balance. It's up. But that's exactly how the laws of leverage and rotation work, and multiplication. So what you do is, if you put a smaller rotor here, like, you know, like an 8 inches or 10 inches instead of the 12 inches, now you're under the law. This do not feel this anymore. Right now I'm feeling it a little bit, but even that I'm still putting out more than what I'm putting in. So the trick is to get that smaller. I just had that. I want to know if I could make, you know, electricity with it, and it does work perfectly. It works. If I would have high RPM to be able to spin that really high, I would probably get about 5,000 volts. 5,000 volts, and it will be a high frequency volt. And I have 3 legs was making voltage. So I have choice. I can create choice of volts, at least 3 levels of volts. So I mean, when it's coming time to, can we loop that? Possible. Absolutely possible. It's just a question of tuning this controller so it work at full potential with my motor. Since now we have an excellent motor to spin, I mean, you can't ask for better than that. It's smooth as pie. Look at that. You know, smooth as pie. All we have to do now is tune the controller and the stator so the controller match the 36 leg stator. I just made a video. I'm sending that tomorrow morning in Anaheim so they can look at it, and hopefully you will have a fairly simple solution. Or you're going to say it's the wrong, we send you the wrong brushless controller. You need to have another one. Well, that's not a problem. You can send the other one. If if they have it, or they can modify this one. So for that thing is, you know, we can loop it up. After that, it's no problem. Actually, tonight I'm recharging my first battery I bought. We did some inverter tests with Ronan, and I'm going to see if I can loop it up with the battery and an inverter and plug a light into the output and charge the battery at the same time for the whole night. So that's going to be my little test tonight. So hopefully you guys, yes, we're there. It's just a question of tuning things up, and we rock and roll. And this motor, I want to show you something. I'm going to turn it to high speed. And I'm try to. You can't stop this motor. You will change sound, but the RPM don't really change. Now I'm burning my hand. So this is why this thing is so powerful. And even in a slow, if I put it really slow, we're talking about 60 RPM, no more than that. Actually, I can time it. It's so slow it won't give me 72 RPM. There we go. 72 RPM. And ouch. You can install it on the top of the surface where the power comes from. Can you imagine on the shop how much power we have here? It's just unbelievable. So I'm going to cut short so I have some time. I'm going to do another test. I'm going to try to loop it up with the battery and the inverter and the charger, and we'll see what happens tomorrow morning. So, cheerio. Well guys, I think we got a loop. Now I'm going to give you what I'm doing here. I use a 12-volt battery. Oh, backward, let's turn that around. 1,000 watt inverter. Roman, you must remember that inverter and that battery. Okay. Now everything is connected and running, and I'm going to give you a reading of what's going on here. And I mean that a very, very powerful light. Like I'm talking like very powerful. So that's what I keep it. As you can tell, look how bright that thing is. Just to show the light's burning, right? But the funny part of the whole thing is when I'm going to show you the numbers. Now the numbers will tell you everything, right? And I'm really turning, like, you know, that's really slow here at right now I think 198 RPM. Now I'm going to disconnect some of the stuff. Sorry for the motion. Now, you guys can't see that? No problem. Now we're going to get some numbers. Okay? So, first thing we're going to get is, let's take a reading of what the generator takes to turn. Okay, here we go. 0.781 of an amp. I got a power for it to turning this generator. Okay. Now, obviously, my inverter is taking power also. Let's find out how much power I'm taking. Between an amp and 0.9 of an amp. Okay. Now, look what I'm doing here. I'm powering a light bulb and I'm powering a cap, which hopefully Let me see there. See if I can show you the cap here properly. There we go. It's an RC 15-37 volts AC. What I'm doing here is very simple. My stator, the green one, comes out with 3 wires, and I can choose how much volt I want. This leg here, what my finger is, produce 118 volts. This leg here produce that one here, and I'm putting my finger on that one there, is 128 volts, and then I can fetch from that side 168 volt AC. So I have a choice for some reason. Now let's go see back here. My charger only take half an amp to run. Right now it's pushing 12.5 volts. It's a smart charger. It will start and stop by itself if the battery goes low. And let's see how much volt I'm pushing in the battery. Okay, I'm pushing in 1.95 of an amp. And let's see how much the battery has been used. 1 amp. So I'm half an amp over unit 8 on recharging the battery, and I'm powering up a light on the top of it. I think that one is 1200 lumen. It's very bright light, extremely very bright. So just to let you know, I'm gonna let that run and keep on running overnight, and hopefully the place won't burn down, and I'll be able to continue with this thing. This is like, it's kind of neat. The inverter seems to be taking it. The smart charger here is stable at 12.6 amp. The inverter is asking question, but it's not getting you know, it's 12.5 volt, and it's keep going. It's asking question, but it's keep doing that, and it's not heating up. No heat whatsoever on all the instrument right now. The charger is cool, the inverter is cold, the controller of the motors is normal temperature, 1 or 2 degrees above ambient temperature, and the stator same thing, nice and cool, you know, a few degrees above ambient temperature, so which is perfectly normal. Actually it's below normal. But this thing is just amazing how much power that thing have at so little RPM. 198 RPM right now. So can you imagine when this thing turn about 10,000 RPM, or even 5,000 RPM, I will be putting thousands of volts out of that green stators. And higher the volt you produce, less resistance you create on the demand. So think about that. Now, so we'll see you in the morning.